How this AI startup recycles 20 million sneakers a year. Hook, it starts with a mountain of shoes, millions of pairs stacked and forgotten. Behind them, hidden in a massive warehouse near Miami, an AI-powered system whirs into life. Conveyor belts, robotic arms, hyperspectral cameras, sorting foam, rubber, fabric, even the glue. Every second, it's dissecting sneakers previously destined for landfills. And somewhere in this chaos is the secret: how a startup now claims to recycle 20 million sneakers a year with artificial intelligence as its brain. Stick around to find out how they built this machine and what happens when material meets machine learning. But before we unpack that, there's one thing you need to know. This isn't just recycling. It's turning consumer waste into industrial-grade raw materials and changing the way footwear is made forever. And to understand how, we've got to start from where this all began. Section 1. The Global Shoe Waste Crisis. Every year, over 20 billion shoes are manufactured, yet the vast majority end up in landfills. Footwear can take 30 to 40 years to decompose, sometimes even longer. That's billions of tons of plastic, foam, rubber, and fabric locked away, unchanged, while demand keeps growing. Sustainability advocates argue that recycling won't fix it unless you completely redesign the system. That's why many brands are racing towards something called circular shoes, sneakers built to be fully taken apart and remade. But that's easier said than done. This crisis made space for innovators, and one startup decided to tackle the raw challenge: turn every component you can into something new. That becomes their ambition, and where that journey takes us next. Section 2. The Tech That Powers. 20 million sneaker recycling meet Pick-Visa, a Spain-based pioneer in optical sorting tech powered by artificial intelligence. Their patented Eco-Flake system scans shredded shoes using hyperspectral imaging to separate rubber, EVA foam, polyurethane, even fibrous textiles with uncanny precision. Picture a factory line. Shredded sneakers pour down a chute, the machine sees glue and foam differences, and high-pressure jets or robotic arms separate each material stream. This precision means fewer mixed plastics, higher-grade outputs, and materials ready to be reused in production. But Pick-Visa didn't build this alone. They partnered with the sneaker recyclers who collect shoes by the truckload and built infrastructure to feed the machine 20 million sneakers per year with near-perfect accuracy. That's where the startup I'm sketching comes in. They mash together collection, sorting, and recycling into a pipeline, and that pipeline looks like this. Section 3. Collection and Sorting, the Miami Model. In Miami, Sneaker Impact runs one of the biggest sneaker drop-off programs in the U.S. They collect over 1 million shoes per year from local gyms, run clubs, and community bins. Mo Hockham, the CEO, explains their model. Gently worn shoes are shipped to developing nations and resold. Shoes past rescue? Those get shredded and fed into recycling streams, forming foam, rubber granules, even sandals made from sneaker foam. But they needed AI-powered partners to scale beyond a few million pairs. That's when they teamed up with PICV-ISA-powered recyclers and built their own centralized facility. Now every shoe dropped off flows into a sorting reality machine. This blend of human collection networks and automated sorting forms the spine of their 20 million pair ambition. But behind that spine lies another breakthrough. Section 4. The Dutch Answer. Fast Feet Grinded's heat breakdown process. Sneakers aren't just foam and rubber, they're glued. That glue contaminates nearly every recycling stream. Traditional grinders would shred, but the pieces stayed mixed. Over in the Netherlands, Fast Feet Grinded claims they've cracked the formula. Their system uses heat and mechanical separation to break down shoes part by part and can process 2,500 shoes per hour. They heat treat to loosen adhesives, then blitz the sneaker into granules sorted by weight and composition. Foam, fabric, rubber, all cleanly separated. That means each material can go back into manufacturing at near virgin-grade quality. Sneaker Impact integrated a version of that process downstream from PICV-ISA sorting, so their facility isn't just optical, it's thermal. That's how they can handle tens of millions of pairs without landfills or low-grade downcycling. Still, there's one more piece. Section 5. Brands designing for circularity. Some brands aren't waiting for collectors. They're building circular sneakers from the start. On's Cloud Neo sneaker is made entirely from a single thermoplastic material, TPU, and offered on a subscription model. You return old shoes, they recycle them. Salomon's Index .01 uses just a polyester upper and a TPU sole, split by scissors for easier recycling. Adidas Futurecraft.Loop used 100% TPU for sole upper laces, meaning total recyclability. These brand efforts reduce complexity at source, but don't address the waste mountains already in circulation. That's where the startup's mass recycling enters, taking every old pair, regardless of brand, and extracting value with AI and heat. Next, the open loop challenge. How do they keep people returning shoes, not tossing them? That's the next reveal. Section 6. Closing the loop, subscription, incentives, and behavior. Collecting 20 million sneakers yearly means behavior change. To ensure steady input, the startup blends multiple tactics. Partnerships with gyms and fitness chains for weekly drop-off bins, as seen in Miami's Palm Springs fitness centers. Incentives: return 5 pairs, get credit toward buyback or local resale. Subscription models inspired by On's Cloud Neo. Members can send back worn pairs to receive new ones, turning recycling into a habit. And they're exploring digital tagging of shoes for traceability, so each recycled pair can be tracked through the PICVISA pipeline and even credited to users. This behavioral layer ensures their facility doesn't run dry, but the real payoff is what comes out. Section 7. Output: foam, rubber, fabric, and industry impact. At full tilt, 20 million sneakers yield thousands of tons of separated materials, clean rubber granules for new soles or sports flooring, EVA and polyurethane foam flakes for mats, insulation, even sandals. Sneaker Impact already makes sandals from foam. Fabric and fibers from uppers spun into new textiles or recycled yarn. These materials are either sold back to brands or used to create infrastructure, play courts, gym flooring, tracks, like fields made from Nike grind materials. With AI sorting, contamination drops dramatically so processors can reuse material at near virgin standards. That changes the math. Recycling becomes cost competitive compared to virgin petroleum-based inputs, but none of this works without scale and demand. We get that next. Section 8. Scaling from local to global sneaker impact started regionally, but the model scales. By licensing their collection and PICVISA-powered sorting blueprint to other cities, multiple hubs feed the same processing line. They're exploring regional clusters, one in US East Coast, another in Europe, maybe one in Brazil or Africa, mirroring Veya's Plastics to Shoes cooperative model. Each hub collects locally, ships standardized shredded material to centralized sorting and recycling plants. Meanwhile, brands like Salomon, On, and Adidas are taking back their circular designs. That creates a dual stream. Return your brand old shoe and any brand recycling. Both feed the same pipeline. If you scale global collection networks, multiple recycling plants, and integrate AI-powered sorting and heat breakdown units, you hit 20 million pairs per year. And beyond. Conclusion. What started as a mountain of sneakers becomes a transformation machine, powered by AI, heat, subscription incentives, and human networks. Each pair, once destined for rotting landfill, now powers foam for flooring, rubber for new soles, fiber for textiles. The startup's real innovation isn't just recycling, it's engineering a pipeline that turns human behavior into material value at scale. The world still makes 20 billion shoes a year, but what if 20 million of them could be reclaimed, reprocessed, and returned to the supply chain? That's 1% recycled at the highest quality, and it's just the beginning. Because in a world addicted to consumption, real change happens when systems adapt. That's the promise here. Old sneakers become new materials, new products, and new business models. And for the planet, that's a loop worth closing.